Hey TCA students, I've got a video for you today about describing graphs. Graphs have been on the news a ton lately as we've looked at statistics regarding COVID-19. Here's one from the New York Times on April 3rd, just a few days ago. It's regarding some of the hot spots in the United States. You can get a lot of information from a graph like this. Are the COVID cases increasing, decreasing? When does it reach its maximum point, etc.? Obviously, we can see here that the cases are increasing, and we all know that we want to get to a point where the cases are decreasing. So we're going to look at how can we describe graphs, some of the important characteristics of graphs. Example 1 is this ray. We can see that it's a linear function. And we're going to start with domain and range. Notice domain is on the x-axis from left to right. So as we look at the graph, we want to see what are all the x values included in this graph from left to right. Well, it starts here at the -3 on the x-axis. That's as far left as it goes. How far right does it go? Because it has an arrow on the right side of this ray, it means it's going to continue to move towards the right forever. So we would say that it's going to keep on going and up to positive infinity. So our domain, this on the left, starts at -3, and notice that the graph does include the point -3, so I'm going to use a square bracket with interval notation. -3 is the leftmost boundary. The right boundary is at positive infinity. Remember, we can never touch positive infinity, so that one's going to get a parenthesis. Domain, left to right on the x-axis. Now we're going to look at range. The range is going to go from bottom to top. From bottom to top, we want to see what are the boundaries. Starting at the bottom, how low does it go? That arrow means that it's going to keep on going down forever and ever. So it's going to go all the way down to -infinity. So our bottom boundary, -infinity. And again, remember, we can't ever touch -infinity, so that's going to be a parenthesis. The top boundary stops at 4. It does touch the 4, so we're going to use a square bracket. Let's move to example 2 and look at domain and range on that example. Domain is from left to right on the x-axis, and we can see we are at -7 on the left and +1 on the right. Both of those endpoints are included in the graph, so I'm going to use the square brackets. -7 on the left, +1 on the right. Range is from bottom to top. How low does it go? And how high does it go? We see that the lowest it goes on the y-axis is at 0, and the highest it goes on the y-axis is at 4. So my range is from 0 to 4. It touches the 0, so I'll use the square bracket. It also touches the 4, so I'll use the square bracket. 0 here on the y-axis, 4 in these spots at the y-axis. Bottom to top. Let's go on and look at domain and range on example 3. Domain from left to right. The farthest left is right here, and the farthest right is over here. So what are the numbers? I'm at -7 on the left, and I'm at 6 on the right. So on the x-axis, I go from -7 to +6. The graph is touching in both of those at both of those points. So I'm going to use the square brackets. -7, comma, +6. Interval notation. Range is from bottom to top. How low does it go? And how high does it go? So the lowest it goes is at -5 on the y-axis. The highest it goes is at 4 on the y-axis. So it's going from -5 to 4. It's touching at those spots, so I'll use the square brackets. So that's domain and range. Now go to the your turn problem and do domain and range. Now we'll look at increasing and decreasing. We'll go back and start with example 1. Increasing and decreasing is referring to uphill and downhill. If you're a little guy standing on that graph right here, going from left to right, are you going uphill or downhill? You're clearly going downhill. So this graph is decreasing, and it begins decreasing here. And again, because of the arrow, it keeps on going all the way to positive infinity. So the decreasing begins at -3 and ends at positive infinity. With increasing and decreasing, the endpoints are not actually considered to be increasing or decreasing. They are just kind of a turning point or a part of it that's not actually changing at all. So I'm going to ask you to always use the parentheses on describing the intervals for increasing and decreasing. This particular graph is not increasing at all. Notice it never goes uphill when you're going from left to right. So the increasing range is none. Let's look at example 2, increasing and decreasing. So if you're a little person standing here on the graph, starting here, you're going downhill until you get to here. That's all decreasing, downhill. So it starts at -7 on the x-axis, and it stops decreasing at -3. Decreasing from -7 to -3 using the interval notation again. I'm going to use the parentheses to show that those endpoints are not really increasing or decreasing. At the -3, we see that it changes direction, and now it's going uphill. Between the -3 and the 1, the graph is going uphill. So that is an increasing interval from -3 to 1. This graph is increasing. Let's look at example 3. Increasing and decreasing. Example 3 is a little bit different because it has more than one section that's increasing and more than one section that's decreasing. I can see that it is decreasing, going downhill between these 2 points. And it's also going downhill between these 2 points. Downhill, downhill. I am going to estimate the values of these coordinates on the x-axis. This point is at -7. This other point is about -4.1, I'll say. So between -7 and -4.1, it is decreasing. But it's also decreasing from this point to this point. That's a -0.5 approximately, and this other one's approximately 2.8. So between -0.5 and 2.8, it's also decreasing. So that is this section and this section going downhill. But notice the other two sections are going uphill. In here and here, the graph is increasing. If you're walking on it, you're going uphill on those sections. So we want to list those intervals as increasing from -4.1 to -0.5, and also from 2.8 to 6. Again, use the parentheses on the increasing and decreasing sections. Now do increasing and decreasing on the your turn problem. Okay, let's go back to example 1 now and look at maximum, minimum, and x-intercepts. Maximum is the highest point on the graph. So the highest point that this graph reaches is right there. The coordinates of that point are -3, 4. So the maximum point is at -3, 4. Notice this one is an ordered pair, not the interval notation. That gets a little confusing to figure out when are we talking about an ordered pair and when are we talking about interval notation. Max and min we're going to represent in ordered pairs. Now the minimum point, because it keeps going down, 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 down with that arrow, the minimum point is just going to be infinity. It never really reaches the bottom. It keeps going. So we're going to say infinity, infinity. X keeps going to the right towards infinity, and y keeps going down towards infinity. X-intercepts. Now x-intercepts is where it crosses the x-axis. And we see that it crosses the x-axis right here at 3, 0. X equals 3. Y equals 0. Which is the point 3, 0. Let's look at example 2. In example 2, the highest point the graph reaches, there's actually two places where it reaches its high point. At -7, 4 and at 1, 4. Again, those are ordered pairs on maximum and minimum. We're going to write it as an ordered pair. The lowest point, the minimum, is right here at -3, 0. And that's also the x-intercept, where it's crossing the x-axis, or at least hitting the x-axis. And example 3, the high point is right here. I'm going to say that's at about negative 0.54. It's kind of hard to tell exactly what that coordinate is. The lowest point for the minimum is right here. And the coordinates for that are negative 4.1, negative 5. X-intercept. This one is crossing the x-axis in a number of different places. It touches the x-axis here, 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 and here. So we're going to list all of those coordinates. So I've got negative 7, 0, negative 2.30, 1, 0, and 5.40. All of those points are x-intercepts.
Okay, you're almost done. Go to the your turn problem and do the max, min, and x-intercepts. Then turn it in. You're all finished.